remember that last week, if you were here, apologies, my children are barking in the background. Sorry about that, guys. If you remember last week, we spoke about some exam prep tips. I've typed those out nicely for you guys so that you can take a screenshot of them this week, okay? But basically, have a timetable, so make sure that you know exactly when your exam is, exactly what time your exam is, where your exam is being held, all right? Stationery, make sure you've packed your stationery ready for your exam. You always run out of a pen in an exam, so have 2 pens, a pencil, a sharpener, an eraser, a ruler, and a calculator. You don't want to be that person the morning of your exam running around looking for your calculator. All right, make sure you've done a study timetable. Okay, not just one that looks really pretty and you've highlighted it and drawn little hearts all over it. That's not what a study timetable is. Make sure you know what you're studying on what day. Okay, stay healthy. Make sure you're maintaining a healthy diet, that you're eating breakfast and a lunch and a dinner, or you're having snacks along the way, or whatever you normally do, make sure that you're sticking to that. Don't pick this time to then go on some sort of, I don't know, yo-yo diet or some sort of fast, or, you know, if it's not a religious reason that you're going on a fast, rather stick to what you normally do, guys. Your body needs as much energy as possible to write exams. Keep a healthy diet. Sleep's really important, especially the night before your maths paper 2 exam. I always say to my students, if you come to school and tell me that you studied until 2 o'clock the night before for your maths paper 2, I'm going to send you home. I'm not going to let you write your maths exam, because you're not ready to write that exam. Your brain has to sleep. It has to rest, especially if you're going to write trigonometry and geometry. Your brain has to rest before you write those 2 papers. Limit your screen time. All those friends who are messaging you on WhatsApp and TikTok and Insta and all those places are going to be there after you finished your exams. These are important exams for grade 11. These are the reports that you're going to use when you're applying to universities. They're going to ask for them. They may ask for these reports eventually. So make sure that you're giving it your all. Take your cell phone, put it in a different room while you're studying. Study, use that time as a break. Okay. Right. The next little point that I've put here is practice. Now, last week I just said practice and I said go look at Google. Okay. I would suggest take a screenshot of what's on my screen. I've given you some websites there that you can go to. So you can Google a site called Stanmore Past Papers. That's a really, really good site. They've got past papers, guys, not just for maths, for every single subject. I'm talking geography, I'm talking accounting, I'm talking consumer studies. Go look at Stanmore Past Papers. It's a really, really useful site. And Eastern Cape Department of Education, they put all their past papers up on their website. For grade 11, normally just the end of year papers, but that's still good practice for you guys. And then if you Google Sharp Maths grade 11, you'll find a whole lot of practice worksheets there as well. Sharp Maths, they've got some free resources available to you. Fantastic, fantastic practice papers for yourselves. Watobe is a great source for you guys to get some lessons. So for the last lesson, you should have been WhatsApped, your parents should have been sent the paper that we did in class. Plus, I also set a paper 1 and a paper 2 for you. I spent my entire weekend doing it. So you should have received those as well. Okay, so that's 3 extra resources that you can use as well. And then I know sometimes you guys are always like, I don't understand why they give us exercises in class and then we don't do them in the exam. Those exercises that you get in class and your homework and things like that, those are to help you build up your stamina for the exam. So take out your books, go see what your teachers have given you for class exercises. Don't do the first 5 because those are all easy. Go to the last few ones. All right. Try do some of the trickier ones. Okay. And get practice in that way as well. So those are my exam preps for you. I really hope you've taken a screenshot of those websites, those suggestions for those websites there. 3 really good sites for you to go get some practice on. Okay. Let us head into our work for today. So last week, if you remember, we started on this question 3, but I thought it would be a really good place for us to restart, right? And to do some trigonometry. So to remind us of trigonometry. Okay, so when you get to the trig section of your paper, all right, when you get to the trig section of your paper, I would start by giving myself some notes. And I used to do this when I used to write some exams back in the day. All right. I used to go start writing the things that I know. So I can see that this question for this trigonometry is going to be based on trig that is on a Cartesian plane. Okay. So trig that's on a Cartesian plane, I know there's a few different things that I must remember. So I must remember the fact that sine, and we can use theta because that's what they've used here. Sine is equal to y over r. Cos of theta is x over r. And tan of theta is equal to y over x. Now, if you can make up a rhyme for that, awesome. All right. I will never forget the rhyme my grade 10 teacher made up for me, and that's how I remember it. Okay. But hopefully your teachers or you've made up some sort of acronym that you can remember those letters by. Mine goes shade your rear, because x-rays tan your exterior. But you can use whatever you want to remember that. To me, the moment that I see trigonometry and we're on a Cartesian plane, I'm thinking x's, I'm thinking y's, and I'm thinking r's. Very different, okay, to where we're thinking opposite, adjacent, and hypotenuse. Yes, you can use SOHCAHTOA. You could try to use SOHCAHTOA on the Cartesian plane. I'm not saying that you can't, all right? But it does make it a lot easier to use x, y, and r when you're dealing with the Cartesian plane as opposed to SOHCAHTOA. All right, so in the diagram, before we carry on, the other thing that I want to talk about quickly before we move on here is when we're dealing with trigonometry on a Cartesian plane, okay, I just want to make some notes here with you guys about the following. Remember that in a Cartesian plane, I have the following. This line here represents 0 degrees. This line here represents 90 degrees. Okay, so I'm going anti-clockwise. So I go 0, 90, 180, 270, and technically this line will also be 360. All right, so we go anti-clockwise when we're measuring it, okay? I see somebody's asking me what rhyme did my teacher teach me. I'm going to write it out for you guys in words so that you've got it just now. It's a really good one. I'll never get it out of my head. Hopefully you guys won't get it out of yours. Okay, so 0 degrees, 90, 180, 270, 360. So again, I'm doing trig. This is the first thing I write down on my page when I'm doing trig. In this quadrant, in the first quadrant, I'm going to tell myself that in the first quadrant, normally that is just theta. So normally I just have theta in that quadrant, or I can have 90 degrees minus theta. So either I'm looking at theta or I'm looking at 90 degrees minus theta. In quadrant 2, I'm looking at 90 degrees plus theta or 180 degrees minus theta. So I'm busy giving myself some tips and hints here about what it is that's going to appear in all these different quadrants. In quadrant 3, I'm normally going to see 180 degrees plus theta, because remember, I'm going anti-clockwise, okay? Or I'm going to see 270 degrees minus theta. Oh dear, already we're going a bit wonky here with our screen today. Okay, and in the final quadrant, I'm going to see 270 degrees plus theta or 360 degrees minus theta. Now, it's important to remind yourself that we don't actually like to use 90 degrees minus theta, but it does exist. We don't like to use 90 degrees plus theta, but it does exist, and we do use it from time to time. We don't like to use 270 minus, and we don't like to use 270 plus. So we're just reminding ourselves here, yes, they exist, but we don't like to use them. Okay, so there exist. Somebody's saying to me, don't we ignore 270 degrees? Yes, that's why I put a line through them. So we are ignoring them for now. Right. I see the same, somebody else, Kat, is asking me about, ma'am, what about negative angles? Guys, I've got a way that I'm going to teach you how to cheat negative angles. Okay, I really do. I have a really good way. So when we get a question in it just now, I've got a good way for you to cheat negative angles. All right, so that is our little Cartesian plane. The other thing that we need to remember is the following. We need to also tell ourselves that in the Cartesian plane, which functions are positive and which ones are negative. So in quadrant 1, they are all positive. In quadrant 2, only sine is positive and the rest are negative. Okay. In quadrant 3, only tan is positive and the rest are negative. And finally, in quadrant 4, only cos is positive and the rest are negative. All right, so some points there for you. Okay, some things to write down before you actually go and you tackle your trigonometry section. All right, where else can you find some revision on trig? You can go back to Watobe's website, you can go look up the trig lessons, or you can go to YouTube, you can go look on YouTube for Watobe's channel, and you can go find the trig lessons on there from grade 11. If you can't find grade 11 ones, go to grade 10. The grade 10 stuff and the grade 11 stuff, remember, it's all trig, guys. It's all trig. Okay. All right, so somebody was asking me, ma'am, what's the rhyme that my teacher taught me? I'm going to give it to you quickly. It goes, shade your rear, cos x rays, tan your, whoopsie, and this got deleted, exterior. Okay, exterior means the outside. All right, I don't know why it's stuck in my head all these years later. I'm not going to tell you what year I'm matriculated in. Yeah, I'm just going to say next year is my 20-year school year anniversary. Okay, my 20-year school reunion, so you'll know. And I still remember that to this day. So come up with something that you're going to remember that you never, ever, ever, ever going to forget. Okay. All right, let's go and tackle this question. I hope that you've taken some screenshots of the notes that we've made so far. Okay, I'm going to bring it back here for you so you can take a screenshot if you haven't had a chance. All right, let's move on to the actual question now. So you are going to, I can almost guarantee you, I can say with a 90% certainty that you will get a question that looks like this in your grade 11 paper, okay? A trig ratio that is on the Cartesian plane, right? So question 1 says, calculate the value of y. Well, let's go read the question. It says, in the diagram, P is the point, -16 is to y, and it's a point such that OP equals 20 units and reflex ROP is theta. So if I'm looking at this, everybody, that means the following. It means that I have got a triangle here, which they've drawn for me very nicely. It is a right angle triangle. If I have a right angle triangle, it means I'm going to use Pythag. They've told me that X is -16. They've told me Y is Y, okay? And they told me OP. So if I go highlight OP, here is OP over here. Now, one of the things you would have learned in grade 8 and grade 9, one of the things you would have gotten drilled into you in grade 8 and grade 9 is The line that is opposite the right angle is the same thing as the hypotenuse. It's called the hypotenuse. It's called the hypotenuse. But when we put it on a Cartesian plane, we call it r, the radius. Okay. So in other words, r, this line, is equal to 20. So I know what x is. X is negative 16 or 16. I know what r is. R is 20. I'm missing y. There's a few things about y that I can take here. Look at y. Y is below the x-axis. If there's a y value that's below the x-axis, what do I know about that y value? I know that that y value is going to be negative. Okay, so it's really important to pick up on these little points, all right? Because that y value is below the x-axis, I know that y value is going to be negative. So let's go calculate our values here. I know I'm going to use Pythag, so I'm going to go say y is equal to the square root of r squared minus x squared, and my reason is Pythag. Now, I could have done it the long way around. I could have gone and said y squared equals r squared minus x squared Pythag. So I'm going to write it on the top here. Right, and then done my next step. Either way is fine. So inputting in my figures, I've got 20 squared minus negative 16 squared. And you see that I'm putting in negative 16 in a bracket squared. I see that some people have done this sum for me. Thank you so much. You guys are going to put in your beautiful scientific calculators and you're going to get negative 12. When you put in your calculator and you do the square root of that, it gives you 12. But you should know that when you square root something, you either get a positive or a negative answer. You go look at your drawing and you see that it is negative. If you go and you make it positive in your answer, guys, they're going to make it wrong. Okay, you're going to have done all that work and you're going to get it wrong. So make sure that you've put that it's a negative answer. All right. Next question. Okay, my next question, let's make some space for ourselves here. It says, determine the value of each of the following without using a calculator. So sine of 180 minus theta and cos of 180 plus theta. Well, we know where theta is now located. We've worked out what the x and the y values are for theta. All right, let's go and write this out for ourselves. So first I'm going to rewrite the sum. Sine of 180 degrees minus theta. I'm going to go to my trusty drawing here on the side. I see that 180 minus theta is in the second quadrant. Okay, what do I know about the second quadrant? I know that sine is positive in the second quadrant. Okay, so that means that instead of seeing sine of 180 minus theta, I can tell myself I've got a positive sign. I'm going to drop the 180 minus, and I'm going to make it sine of theta. All right. Then I'm going to go to my little rhyme, which very nicely Kia wrote for you guys in our chat. Thanks, Kia. Thank you so much for that. So sine, when we think of sine, we're thinking shade. And I always like to put it in pencil next to my space here. Shade your, whoopsie, that's not a Y. What am I doing here? Shade your rear. Okay. So I've just calculated that Y is equal to negative 12. And earlier on, we did that R was 20. Put that into my calculator to simplify, and it gives me negative 3/5. Nice and easy. All right. If I do cos, so they've given me their cos. Oh, they've given me cos. Cos, sorry guys, of 180 plus theta. Okay. I go to my trusty drawing. Where is 180 plus theta? 180 plus theta is in this quadrant over here, quadrant 3. What do I know about quadrant 3? In quadrant 3, I know that only tan is positive. So what will I know about cos? Cos will be negative. So I'm looking for negative cos theta. Okay, so shade your rear cos x raised. So I'm looking for x over r. I'm going to leave the negative on the outside. My x value is negative 16 over 20. I put that in my beautiful scientific calculator, and I get 4 over 5. All right, have a look at those two sums for me. Have a look at those two sums for me. Take a screenshot. See if there's anything you'd like to ask me. I'm going to give you a few minutes to see if there's anything you'd like to ask. Okay. All right. Just a reminder, if you guys are sending me private messages, guys, I don't have time. I'm not going to have time to read the private messages and teach you. We've got to try to get through these 3 questions today. Okay. All right. Alona's asking me, can we still simplify even though they said we mustn't use a calculator? Love this question. Remember when you guys were in primary school and if it said you mustn't use a calculator, they used to come take the calculator away from you if you were using it? They're not going to do that to you in your maths exam. Okay. If you get negative, open brackets, negative 16 over 20, right? And you put that in your calculator. Yes, you can do that in your head. I'm not saying you can't. I'm sure that most of you guys can do that in your head, okay? I'm sure you can, all right? But to put that in your calculator simplify for you, it's going to save you so much time. So small sums like that, Alona, no, they're not going to subtract marks. All right, small sums like that, they're not going to subtract marks because that is very, very small simplification sums. Okay, so no, they're not going to deduct marks for something like that. We're still showing our steps of how we got there. We all good. Right. Do we make it an angle? I'm not quite sure, Cassandra, what you mean by do we make it an angle? You're going to have to just maybe clarify that for me. I'm going to give you a few seconds to just see if you can clarify. I'm not really sure about what you mean about do we make it an angle by inverse of cos. So no, you don't need to make it an angle by making it inverse of cos. You can do exactly what I've done there. So much simpler. Don't go make it any more complicated than what we've done. I really wouldn't suggest making it more complicated. Keep it simple, keep it moving. Okay, any other questions? No one else has got any more questions. Are you guys sure? Okay. You sure? All right. Do we then substitute the answer into the formulas? No, there's no reason for you to have to substitute anything into the formulas. That's what they're asking for. They're asking you to determine the value of those equations. So you're done. You've determined the value of those equations. A was the sine of 180 minus theta. So that's equal to negative 3 over 5. B was the cos of 180 plus theta, and that was equal to 4 over 5. Okay, and you're done. That's it. All right, no need to substitute into anything else. Okay, I'm seeing a lot of people asking Kia in the chat, what is in paper 1? Please go back and check. Kia's told you guys twice now in the chat. Go back, have a look. It's definitely there. Kia has put it there for you guys as well. All right, we're going to move on. Okay, we're going to have a look at number 3. Number 3 now says to us, S is a point on OP such that OS is equal to 50. Oh, so much words. I hate it when they put so many words in maths. Determine the coordinates of S without the use of a calculator. All right, let's go have a look. Let's go see what they're telling us. So they're saying, I'm just going to clean this up a little bit for myself. Okay. Let's erase this highlighter as well. Okay, they're saying S, here's S over here, guys. So OS, this line, okay, is 15 units. Okay, so OS is 15 units. They want us, right, to determine the value of S. So this value here, the coordinates are X's to Y. I don't know what X is yet. I don't know what Y is yet. Okay. Without the use of a calculator, which gives some of us a few heart palpitations, I'm not going to lie, me too. Okay. All right. What are we going to do? Let's have a look at it. Well, even though this is OS, let's have a look at the theta. Has the angle, the size of the angle, so I'm going to highlight theta in yellow. Has the size of the angle changed? No. That angle is still lying on that line, OS. Okay, so the size of the angle is still lying on that line, OS. So would it be fair to say, everybody, that sine of theta, right, that we calculated just now, sine of theta that we calculated just now, okay, I'm going to erase this quickly. So we got some space. All right. Earlier on, we said to ourselves that to get the sine of theta, it would be the same as saying negative, where am I? There we go. It would be the same as saying negative 3 over 5. Are you happy that that's how I can one way to calculate theta? By saying sine theta is the same as saying negative 3 over 5. All right, we already got that earlier on. That was for 3.1.2a. So sine theta equals negative 3 over 5. In this case now, remember that sine is the same thing as saying shade your rear hair. Okay, so for this line that we've just calculated, or this line that we're trying to get now, OS, we don't know what the Y value is. So I'm going to put in Y here for the moment. All right. What do I know about the R value of OS? What do I know about the R value? Have they given me a value for the R value? Yes, they have. Hey, they told me the R value will be 15. So another way that I could write it for you is I could say this. Sine of theta is equal to negative 305. We got that in the previous answer. Okay. I could also say, but sine of theta is also equal to, I don't know what the Y value is there, over, what's the R value? It's 15. So that's another way that I can write it. Either I can say sine of theta is equal to negative 3 over 5, which I just calculated, but it's also equal to the Y value of OS over the R value of OS. So that means, okay, that means that, all right, I can say, therefore, I'm going to take it up here so I got more space, negative 3 over 5 is equal to Y over 15. So negative 3 over 5 is going to be equal to Y over 15. Why are those two equal? Because they're both equal to the sine of theta. They both lie on that same line. They're both equal to that same angle. Okay, somebody's saying to me, why am I choosing to use sine theta instead of the other trigs? So the other trig, you can use any one of them. We'll do another one now so you can see that it works as well. Okay. All right, I'm just trying to find my Y value first. We're going to have a look and see if we can get the next one now. Okay, so You can either cross multiply now, or you can say to yourself, well, to get to 15, what did I do? I times by 3. So what must I do to -3? I must times it by 3. I'm going to cross multiply for you. I find that easier for myself. So I'm going to say 5 times y gives me 5y. And -3 times by 15 gives me -45. Divide both sides by 5, and I get y is equal to -9. All right. So somebody's asking me, so ma'am, can we multiply 3 on the top to get the answer? Yes, you can. What would you get? You'd say -3 times by 3 gives you -9. Therefore, y equals -9. What else have we just done? We've just done that cos theta. I'm so sorry, guys. Cos theta is equal to, what did we calculate cos theta equal to earlier on? We calculated it to negative, oh, apologies, was 4/5. No, yes, sorry, I've got the wrong thing written down here on my page. 4/5. Okay, so cos theta was equal to 4/5. Okay, our page is doing all sorts of weird and wonderful things here. Apologies, guys. I'm just trying to get it to work again for us. So cos theta equals 4/5. Sorry. So I'm gonna talk while I try and fix it. Okay, but what else do I know about cos theta? What else do I know about cos theta? I know that cos theta is also equal to what? What else do I know about cos theta? What else is it equal to? In terms of my new line. In terms of my new line. Good. Okay. Share your rear, cos x raise. Hey, x raise. So let's try get our pen working again and see if it will work. Oh, unfortunately not. Okay. See if we can get this to work. Oh my goodness. It's just doing some weird stuff now. Okay, so I'm going to go write it down here. Because theta is equal to 4/5. But we said cos theta, share your rear, cos x raised. So I don't know what my x value is. I do know what my r value is. My r value is equal to 15. So I can say, therefore, 4/5 is the same as saying x over 15. I'm going to cross multiply. So I'm going to get 5x equals 60. Divide each side by x. And so therefore I get x is equal to 12. Okay. All right. So Kat is asking me an excellent question. Kat saying, shouldn't x be negative? Kat, I completely agree with you. X should be negative. So I'm going to put as my final answer. Therefore, S is the point. -12 is to -9. Well done, Kat. Okay. All right. Does anyone have any questions before we move on? Anyone who has any questions? Anyone who wants to ask anything? Are we all good? All sure? Okay. All right. Moving along then. So my next question is a big one. It's a 7 marker. We spoke about this last week. When you get these big questions, okay, and you start freaking out, I want you to take a breath and I want you to calm down in the exam. If something is for 7 marks, how many minutes should it take? Tell me in the chat, please. I'm sure your teachers have gone over this with you many times. 7 marks should take you how many minutes? Thank you, Annie. Thank you, Zandasile, Sonic, Sakile. Good. 7 marks takes you 7 minutes. If you have not finished the question in 7 minutes, you move on with your life. You forget about it, okay? And you pass on this question. Okay, 7 marks, 7 minutes. Another thing that often happens with students in an exam, and I'll tell you, I've been there. I probably did it as well when I was in grade 11. You see 7 marks and you start freaking out because you start thinking, oh my gosh, it's 7 marks. That means it must be the hardest question in my whole paper. That is not true. It's really, really not true. So you need to get your brain over that fact. If you see a 7 marker in the exam, you tell yourself 7 marks, 7 minutes, move on. Right. Simplify, and our worst question that we hate as students without the use of a calculator. Okay. And then they've given us a fraction. Now, we are going to treat this step by step. We're going to take the numerator and the denominator separately, and we're going to see what we can cancel out. That is our goal. Okay. So, first question we've got here, it says, I'm going to go, guys, and I'm going to give myself some space on the side here and rewrite the question just so that I have some space to work it out. I'm going to leave this drawing here for myself so that we can come back to it because we're going to need that. So I've got cos of negative 33 degrees. There's that negative angle you guys were asking me about earlier on, times by the tan of 147 degrees over 2 cos 303 degrees times by the sine of 240 degrees. Right, so you want to teach yourself a trick for negative angles. You want to get over negative angles for life? You do the following. If you see a negative angle, to make a negative angle a positive angle, all you have to do is the following. You say cos negative 33 degrees plus 360. So to take an angle from a negative angle and make it into a positive angle without affecting anything, you add 360. When you add 360 to an angle, all that does is it takes it from where it is. So let's say that it's sitting, I don't know, over here. If you add 360 to that angle that's sitting over there, all you're going to do is you're going to go around. Is that going to affect the angle at all? Nope. But what it is going to do is if they've given you it in a negative format, it's going to make it positive. So the moment you see a negative angle, add 360 to it, going to help you guys. Okay, so I've got cos negative 33 degrees plus 360 times by. Now we're going to go work out all these 147s and all the rest of it. Right, 147 degrees. 147 degrees is definitely greater than 90 degrees. So it's greater than 90 degrees, but it's less than 180. So which quadrant is that sitting in? It's sitting in quadrant 2. What do I know about quadrant 2? I know in quadrant 2, sine is positive and tan will therefore be negative. So negative tan. Okay. And what happens in this quadrant? I'm going to say 180 degrees minus 147 degrees. Okay. Over. Rid of that teeny tiny little points. Over. All right. On my bottom here, I'm going to leave the 2 where he is for now. Cos of 303. So cos of 303. 303 is greater than 270, but less than 360. So that's falling in my quadrant number 4. What do I know about quadrant 4? In quadrant 4, cos is positive. So I'm going to leave cos as positive. In my bracket, I'm going to say 360 degrees. Okay, 360 degrees minus 303. degrees times by 240. 240 is greater than 180, but less than 270. So we're dealing with quadrant number 3. What's happening in quadrant number 3? What's happening in quadrant number 3? Okay, I'm either going to have 180 degrees plus theta, or I'm going to have 270 degrees minus theta. So I've got sine, and guys, I'm actually losing my mind here a little bit. I've gone and I've rushed ahead and I haven't thought about something for you guys. So I'm coming back here. I'm going to go and erase these little things that I've added here. Apologies. Let's go erase this quick. Apologies, and erase this quick. I'm coming back to those. Okay. Sine, and it's going to be 180 plus. What do I know about quadrant 3? Sine is going to be negative. Okay, why have I gone and left all of those pluses and minuses? Why have I gone and subtracted them? Because of the following. Whatever is left inside of that bracket, guys, needs to be equal to what was originally here. So to get 147 degrees, what was it? It was 180 degrees minus 33. 180 degrees minus 33 gives you 147. How did you get 303 degrees? 303 degrees, it was 360 degrees minus 57 degrees. And for the last one, how did you get 240 degrees? It was 180 degrees plus 60 degrees. So whatever is left inside those brackets, whatever you've got in those brackets, needs to be the same as the angle. So you see this bracket, 180 minus 33 gives you 147. Okay, I'm going to highlight another one. 360 degrees minus 57 gives you 303. So that's what we're doing in those brackets. All right. Finishing this off. I told you earlier on, when you've got a negative angle, you go add 360. So if I go say 360 degrees minus 33 degrees, it gives me cos of 27 degrees. Times by, here I've got 180 minus, so I'm going to have negative tan 33 degrees. Over on the bottom, I'm leaving 2 where he is. I'm going to have cos, dropping that, of 57 degrees times by negative sine. I'm dropping the first part of 60 degrees. Okay. All right, so I'm going to fast track this cos one. I know 327 is in the 4th quadrant. It's greater than 270, but it's less than 360. So cos of 327 is going to be positive cos 33 degrees. Times by. I've got cos, tan, and then sine. I'm not liking seeing tan in that. I don't like seeing tan. Why don't I like seeing tan? Because I've got sines and coses everywhere else. But what do I know about tan? I know that tan is the same thing as saying sine of 33 degrees over the cos of 33 degrees. So tan is the same thing as saying sine over cos. Good, Annie, nice. Over. Okay. There's a little trick. There's a little trick up my sleeve. And my trick is as follows. My trick is as follows. What do I know about, well, first of all, before I do the trick up my sleeve, I'm seeing 33 degrees here. I'm seeing 33 here. I'm seeing 33 here. And then I got this weirdo 57. I got this weirdo 57. Okay. On my calculator, take your calculator and say to you guys, 90 minus 57. What does it give you? Do 90 minus 57 for me. What do you get on your calculator when you do 90 minus? Nice, well done. You get 33 degrees, hey? Okay. What do you know about cos and 90? What do you guys know about cos and 90? What happens if you see cos and 90 together? What is it going to change into if you ever see cos and 90? So cos, good, nice. So do you agree that the cos of 57 degrees, okay, is the same thing as saying this? It's the same thing as saying 2 times the cos of 90 degrees minus, whoopsie daisy, minus 33 degrees. Because remember, whatever's in that bracket needs to give me 57. And so what am I working my way up to here? If I'm seeing cos and 90, I'm working my way up to seeing what, guys? Good. I'm working my way up to seeing sine. Well done. Times by 60 degrees, sine of 60 degrees. Would that perhaps happen to be one of those special angles that they made you learn off by heart? Remember 60 degrees anywhere? Yeah? Yeah, okay. 60 degrees, one of those special angles that they made you learn off by heart. Okay, it's definitely one of those. If I'm looking at my special angles, I'm going to go make a note for you guys on the side here. All right, so how do I remember my special angles? I go tell myself, I've got a point here, 30, 45, 60, and I give myself a point there. Okay, so I'm giving you a note here. So this is a really good screenshot opportunity here for special angles. All right, I like to use Cartesian planes, as you can see. Okay, I'm going to do it in red. So this will be my 0 degrees. This is my 30 degrees. This is my 45 degrees, my 60 degrees. This is my 90 degrees. Okay, so giving you guys a screenshot here. Thank you, Kat. Absolutely. Kia, sorry. Keep saying Kat because I keep seeing Kat's name here because Kat gave me changes the sign. Kia, thank you so much. It is a screenshot moment, everybody. So I know I'm going to have to open up brackets when I have Cartesian planes. So that's what I do to myself. Okay. And I'm going to say the following. So all along the y-axis, what do I know about the y-axis? All along the y-axis, my x values are 0. So I always start there. Tell myself, all along the y-axis, my x values are always 0, hey? So 0, then I go 1, 2, 3, and 4. Then I go the opposite way. I tell myself, all the way along the x-axis, what do I know about my y values? My y values are 0. And then I go 1, 2, 3, and 4. Because I always use Pythagoras, what must I do? I square root all of these. Okay, you can learn them off by heart if you want to. This is the way that I learn this. This is the way that I learn this. Okay, I draw this out for myself. Okay, tell myself all the way along the x values, x is 0. Then I go 0, 1, 2, 3, 4. Do my semicolon. All the way along the y-axis, the x-axis, my y values are 0. And then I do my y values, 0, 1, 2, 3, 4. And then what do? I square root everything. Right? Hope we all good with there. Okay. If I had to go and calculate my R value, okay, if I had to go calculate my R value for all of these guys, I can already tell you that for these, my R value is going to be 2 each time. Okay, so for every single one, R equals 2. So if they had to tell me negative sine of 60, I'm going to go put my negative in, and I'm going to go to my 60 line. There's my 60 line over there. Okay, here's my 60. I'm going to go highlight it for you guys. Here's my 60 line. Okay, so sine. Remember my rule I told you guys just now from my teacher when I was back in those days? Sine, shade, your rear, hey? So I'm looking for the y value. The y value for this is root 3 over rear, which is 2. If you go to your calculator right now and you put sine of 60 in, see what it tells you. And remember, you're not allowed to use calculators for this. This is an easy one, so you could. But if you had to go to your calculator right now and you put sine 60 in, it's going to give you root 3 over 2. Guys, I would suggest use this. It's a really, really good, easy way for you to get nice marks in this section. Okay. Screenshot it. Make sure you've got it. All right. It's going to help you. I know, trust me, we all use the calculator when it comes to this kind of question. I know, even though it says don't use a calculator, I know you guys are going to use a calculator, but if you've got this, you don't need to use your calculator. You can get your full marks. No one's going to take your marks away from you. Okay, let's carry on with our question. So, on the top here, would you agree that I can now go and I can cancel this and this? Gone. They're canceled out. Numerator and the denominator are now gone. And on the top, I'm left with negative sine 33 degrees for the moment. On the denominator, can I go do this? Can I go say this and this are gone? I'm canceling those two out. Okay. Remember we said whenever we see cos of 90, it's going to become sine of 33 times by negative root 3. Okay, hope you all still with me. Negative and negative are going to cancel. Sine and sine are going to cancel. Now be careful, I'm still left with 1 on the top. So my final answer is 1 over root 3. In a matric final, if you put that, you'll get your full marks. Okay. If you've got a really strict teacher, though, if you've got a really strict teacher at school, all right, which I see some people who've got their cameras on are laughing and nodding their heads at me, all right? So if you've got a really strict teacher at school, okay, then you need to do what they call rationalizing this, all right? So a way to get around that is you put 1 over root 3 on your calculator and you get an answer, or you go rationalize this. So you multiply it by root 3 over root 3, and your final answer is root 3 over 3. Okay, so if you've got a really strict teacher at school, they'll want you to rationalize that. And so we're going to rationalize it. Okay, I see, Tato, you're asking me to repeat 3.2 again. Of course, I'm going to repeat it for you. Let's go through it, the steps that I've got here. Let's have a look at what we did. So, step 1. What did we do for step 1? I would suggest always rewrite the question. For trig, it's really important. As you're rewriting, things are going to get going in your brain. Okay, my second step, I went and said to myself, well, I had cos of negative 33 degrees. If you have a negative angle, guys, a really good tip, add 360 degrees. The moment you add 360 degrees, it's going to turn that into a positive angle. It's just going to help you. Okay, so cos of negative 33 degrees plus 360 times by. Then I said to you, remember, whatever you put inside your brackets must equal what the angle is. So 180 degrees minus 33 degrees gave me 147. So I've got negative tan 180 minus 33 over 2 cos. How do I get 303 degrees? It's 360 degrees minus 57 degrees times by. If I look at these angles, apologies, I've skipped a step. So tan of 147 degrees, we said that's the second quadrant. What do we know about tan in the second quadrant? Because I saw somebody did ask me earlier on. What do we know about tan in the second quadrant? Tan is negative. So we must also put a negative here, which is what we did, hey? Okay, so we made it a negative. All right. Then what happened? We went to the bottom. We saw that cos was in the third quadrant there. Fourth quadrant. So that was fine. Sine of 180 plus 60 degrees. That's the third quadrant. We know that sine is negative as well. Next step. Negative 33 degrees plus 360 gives me 327 degrees. So I've got cos of 327 times by, we're keeping negative where he is, so negative tan 33 over 2 cos of 57, because 360 is in the fourth quadrant and cos is positive in the fourth quadrant, times by negative 60 degrees. Okay, what was left to do? What was left to do was for us to simplify. We had cos of 33 degrees times by, we said, keeping the negative, tan is the same thing as saying sine over cos, over, we keeping the 2, we said cos of 90 degrees minus 33, because we didn't like seeing 57, times by, we went and I taught you that special trick, okay, with your special angles, and I got negative root 3 over 2. Which was equal to, then we started doing some canceling. Okay, we saw that I had cos of 33 could cancel with cos of 33. All right, I saw that on the bottom. On the bottom, I had a numerator of 2. Okay, I had a numerator of 2 and a denominator of 2. So I canceled those 2's out. So they cross-canceled. Cos of 90 degrees minus 33 was the same as saying sine of 33 degrees. And I was left with negative root 3 on the bottom. Then we saw that the negative and the negative could cancel, the sine and the sine could cancel, and I was left with 1 over root 3, which I then rationalized and got root 3 over 3. All right, so I hope that you've got that. I hope you managed to get a screenshot of the special angle once again. Remember, this lesson will be on the Watobe website and will be accessible to you guys. All right. See, trig's not that bad. Okay. Right, moving on. Use trig identities. Oh my goodness. Okay. Do not panic when you see the words use trig identities, everybody. You get given a formula sheet, especially for paper 2, you will have a formula sheet. And because you have a formula sheet, using trig identities makes your life much, much easier. I can tell you that when I was in matric, they didn't give us our trig identities. They used to make us learn them off by heart. It was like we were being tortured. All right, so at least we have a formula sheet, okay? We know where it is. I see that Isa is asking me, when am I going to send this question paper? Isa, it should have already been sent to you during the week. I did send it to Watobe on Sunday. They should have sent it to your parents already. Okay. If not, please message them, email them, and ask them for it. All right. So use trig identities to prove that the sine of, sine cubed x plus sine x times cos squared x over cos x is equal to tan x. So they're asking you to prove that one side is equal to the other side. If it is a prove that question, we're doing left-hand side, right-hand side, left-hand side, right-hand side. Okay. All right, so on my left-hand side, on my LHS, let's go have a look at this. I go and I write it out for myself. I say on my LHS, it's equal to sine cubed x plus sine x. Board is doing all sorts of weird things today. Sorry, guys. Sine x times cos squared x over cos x. Okay. Exam tip here. Use the paper. Use the paper. They give you the paper. Use the paper. Do not try to squish trig identities on one little line. Spread it out. If you get given a fraction, put it on 2 lines. Everybody, use the paper. Okay. If you're going to squish this into one tiny little line, you are never going to see what's happening. Use the paper. Use the space. Okay. So I cannot tell you how annoying it is when a student has tried to squish everything into and tried to save the paper. All right. This sounds terrible, but it's not a geography exam. If it was a geography exam, sure, I'd be worried about you wasting the paper, but this is not geography. It is maths. In maths, Kia can tell you, we're not really worried about the paper. Okay. We want you to use as much paper as possible. All right. We want you to make sure that you are getting the right answers. And the only way to do that, everybody, is to make sure that you are using the paper. So please, 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 if you're writing a fraction, put it over 2 lines. Okay. Right. Moving on. On the top, I'm seeing sine, and I'm seeing it a lot. I've got sine to the power of 3 plus sine times cos to the power of 2. Okay. My trig identities, the one that we've been practicing this year, that you guys should have gone over a whole lot without even looking at the formula sheet, which I see some of you are saying that you guys don't get given. You should get given a formula sheet. I can tell you and promise you that in matric, you will get given a formula sheet. They have to give you a formula sheet. Okay, so the one that you guys have been practicing a lot is this one. Sine squared theta plus cos squared theta equals 1. So that's the one you should have been practicing a whole lot in class. So that's what we're aiming for here. We're aiming to get something that looks like that. Well, if I look at that top sum, I see, what can I take out of that? What can I take out of my first term and my second term? Is it fair to say that I can take this out of my first term? Open brackets. I'll have sine squared x plus cos squared x over, on the bottom, I'll have cos x. So all I did was I went and took sine x out as a common factor. Okay. I'm going to leave sine x where he is for now. It was my goal to get sine squared x plus cos squared x. What do I know about that? I learned this year it's equal to 1 over cos x. Sine x over cos x is the one we learned in grade 10. Okay, you know that one. Sine x over cos x is equal to tan x. Make sure you finish off the question. Is that what they asked us to prove? Let's double check. Yes, it is. They said prove that that equals tan x. So therefore, it's equal to the RHS. Okay, making it a bit smaller for you guys. So if you want to screenshot that, you can. Right. Okay. Grab it, get it in a screenshot. Let's have a look at the next question. Right, next question says, solve for x if sine is equal to 0, 142. So solve for x if sine of x is equal to 0, 142, and x is an element between 0 degrees and 360 degrees. So moving over so that I can see it on my side. Okay, make some more space for ourselves here. All right, let's have a look. Okay, So solve for x if sine of x is equal to 0, 142. So sine x equals 0, 412. All right. They told me x is an element between 0 degrees and 360. In other words, I can go anywhere in the 4 quadrants, but I can see that x is positive in this case. On my calculator, what are the buttons I'm going to press? I'm going to press Shift X 0, 412. Shift X 0, 412, guys. And what can I go and say? Well, I know x is in the first quadrant, so I can say straight away, x is equal to 24,33 degrees. Or x is going to be equal to, so what do I know about sine? Sine's positive in quadrant 1 and quadrant 2. So in quadrant 1, sine theta, so sine x. And in quadrant 2, I'm going to say 180 degrees minus 24,33 degrees, which gives me 155,67 degrees. What do I need to include to make sure I get all the right answers, especially if I got a really strict teacher? I mustn't forget, x is an element of real numbers. Okay. All right. Hopefully you've got a screenshot of that one. Let us move on. Consider the following equation. I've got tan of 3x plus 2,67 equals 0. Determine the general solution. So now we're doing general solution. Okay, general solution, a little bit different to the one we did above. The one above, we just solved for x. Now we're determining the general solution of that. Hence, or otherwise, solve for x if negative 90 degrees is less than or equal to x and 90 degrees. Okay, so general solution, pretty much what we've just done, but we're going to throw k in the mix here, hey? Okay, so we're going to have that k in the mix. So first of all, let's write it out. We've got tan of 3x plus 2,64 equals 0. So that's the first thing we've got. I'm going to leave tan where he is. I'm going to take this number to the other side and I get negative 2,64. Right. Now, because I'm doing general solution, there's a way that I need to set out this question. At this point, I need to tell myself that I am going to have a reference angle. So I'm going to be lazy. I write it out like that. Some teachers will make you write the entire word out. I wasn't very good at spelling at school, so that's how I write if reference angle. Nothing wrong with writing it like that. You'll still get your full marks. So on my calculator, now you've also got to be careful, everybody. Okay, when you put this into your calculator and you're looking for a reference angle, you never put in the negative. So on your calculator, you're going to put shift tan of 2,64. Shift tan of 2,64. So you never put in the negative. Please, please, please do not forget. You do not put in the negative when you're looking for your reference angle. So put in your calculators for me. Shift tan 2,64. What do you get? Nice, Mesh. You get 69,25 degrees. Good. Okay, you do not put in the negative when you are looking for your reference angle. And this is the way we set it out when we are doing general solution. Okay. All right. Now, what is it that we know? What is it that we know? Okay, we know the following, right? We know that tan, okay, is negative. And if we go back here, all right, we've got tan of 3x equals negative 2,64. So we know in which quadrants, guys, is tan negative in? In which quadrants is tan negative? Well, if I go draw a little diagram here, I know that tan is going to be negative in this quadrant, and I know he's going to be negative in that quadrant, 2 and 4. That's right. 2 and 4. Cool. Okay. So I'm going to go tell myself, well, if he's negative in quadrants 2 and 4, it means that in the second quadrant, 3x is going to be equal to, in the second quadrant, what do we always say? We say 180 degrees minus, okay, 180 degrees minus what gives me 69,25? 180 degrees minus what gives me 69,25? 180 minus 110, well, I haven't left myself much space here, sorry. 180 minus 110, comma, 75. Okay. Plus, we are dealing with tan, everybody. We are dealing with tan. So when we deal with tan, we would normally say, okay, let's not worry about that for now. Okay, let's just do it as our normal. Let's go do our normal. So plus k times 360. Okay, so second quadrant, 180 minus blah, plus k times 360. So I've got 3x equals, right, 180 minus that, so 180 10 degrees, comma 75, comma 75 degrees plus k times 360. Okay, somebody's, yes. Okule, yes, absolutely. That's why I was going to say 180. Yes, absolutely. So you can say 180. Ma'am, don't we subtract the reference angle from 180? Yes, so that's what we have done. So remember earlier on, I was saying to get this, we're doing that. So to get that, what's in there, we're getting that. So I'm actually going to put this in red for you guys, because this is an extra step that I've done for you. Normally, you would go straight to the step down here. All right. Yes, you can say K180. That means that you're going to get one answer. I'm doing in terms of two answers for you guys. Okay, so K times 180 is going to give you one answer. I'm doing it in terms of two answers for you guys. So I'm doing where you do second quadrant and you do fourth quadrant. But saying times K times 180 is also fine. All right, what am I going to do on both sides? I'm going to divide by 3. So I'm going to get x is equal to 36,92 degrees times k times 120 degrees. K is an element of real numbers. So that's the second quadrant. All right. And I also said it's also in the fourth quadrant here. Fourth quadrant. So this time I'm not going to do that extra step for you. I'm going to go straight into 3x is equal to, what do I know about the fourth quadrant? The fourth quadrant is 360 minus. So if I go and say to myself 360 minus the reference angle, okay, 360 minus the reference angle, I'm going to get 290,75 degrees. I promise I'm going to answer all your questions now. Plus k times 360. I then go and divide both sides by 3, and I get x is equal to 96.92 degrees plus k times 120. K is an element of 1. In other words, I have 2 sets of answers here. Okay, let's go answer all your questions. So you guys have said, man, don't we subtract the reference angle from 180? Yes, remember I said to you, I did that extra step for you, and that's why it's in red. Ma'am, if we don't write k times 360 times k, will I still get the full marks? All right, no, you have to say plus k times 360. It's part of the sum, because remember what we're doing here is we're saying that this is going to carry on forever. So when we do graphs next year, I'm going to draw a little one here for you. Next year, you're going to put it onto a graph. Okay. And so you'll see that tan's going to look like this, and tan's going to look like that, and tan's going to look, and it's going to carry on going forever and ever and ever and ever and ever and ever and ever. And what you're actually calculating here is you're saying that tan is 36.92 degrees. So he's like equal to there somewhere, and he's equal to there somewhere, and he's equal to here, and he's equal to there. Okay, so you'll just carry on going and going and going and going and going. So when you do graphs next year and you see it on a graph, it's going to be beautiful. Everything comes together. It makes so much sense. Okay. All right. Any other questions for that one? Otherwise, I'm going to move on so we can finish this off. All right. Okay, let us have a look. It then says to us, hence or otherwise solve for x if it's between negative 90 and 90. So if it's between negative 90 and 90, okay, if our thing is between negative 90 and 90, well, then what we're going to do is we're going to do the following. If it's between negative 90 and 90, guys, is we will say, okay, we'll go x is an element. All right. So this is one way you can write it. X is an element. Okay. Now, I would take my answer. So you can take either answer, really. I'm going to start by taking my, I don't have my calculator on me. Let's get my calculator up on the screen. Okay. All right. So I would start by taking my 36.92 degrees, and I'm going to subtract, right? I'm going to subtract 120. Why am I subtracting 120? Because that's what K was an element of. So I start with my 36.92 degrees. That's this value up here. And I subtract 120. And I get my first value, which is negative 83.08 degrees. I check, is negative 3.08 degrees between or above negative 90? Yes, he is. So I'm good with that one. All right. The next one I would then go to is I would then go to my next one that I've got here. So I would go to my, put it in highlights for you guys. I would go to this buddy. So I've got 96.92 degrees, and I'm going to subtract 120. Right. And he's going to give me negative 23.08 degrees. And the last value that's going to fall into my 90 degrees is which one? Which one falls in? 36.92 or 96.92? It's the 36.92 degrees. Okay, so what did I go and do? I took my values and I subtracted y 120 because that's what K was an element of. That's what K was an element of. And that's what's being repeated each time. Okay. All right. Let's have a look at our last trig sum for today. Okay. Is saying K is an element of X the same as saying K is the variable of X? So I haven't heard it said like that before, to be honest with you. But if that's how your teacher has taught it to you, then perhaps when we say K is an element of X, so we've said K is an element of real numbers. We haven't said that K is an element of X. So we always say that K is an element of real numbers. Sometimes we can also say K is an element of Z. So that'll give us integers as well. Either one, as long as you've said it. Yeah, I haven't heard it said that K is an element of X or K is a variable of X, to be honest with you. All right, last one for today, guys, on trig. Solve for X. If that is our equation, I'm going to go and give us some space here. Let's go give us some space very quickly. Okay. All right. Again, please make sure that this paper has been sent to you. I did send it on to Watobe for them to send it to you. I'm sure that they have. Perhaps you just haven't received it yet. If you haven't received it yet, go and have a look online. It is a past paper that I used today. So yeah, you will be able to find it online as well. Okay. So 4.4. Solve for X if 4 sine squared X plus 7 cos X minus 4 equals 0, and X is an element between 0 and 360. Okay, so let's go write some out. That's the easiest thing to do when we're starting out. 4 sine X, 4 sine squared X plus 7 cos X minus 4 equals 0. Okay. All right. Now, we need to try and simplify this as much as possible to try and get it to make sense for ourselves. So if I'm looking at the sum, I'm seeing sine squared X, and then I'm seeing cos X, and I'm seeing 4. So it's kind of looking like a quadratic equation for me, except I'm seeing sine instead of cos. But do I know a way, okay? Do I know a way to get to this answer? So do I know a way to get to this answer? All right. Yes, there is definitely a way to get to this answer. What is it? I can use what I have learned this year. What have I learned this year? Okay, I have learned to do the following. I have learned that sine squared X plus cos squared X equals 1. Good. And somebody's told me there in the chats that sine squared X is the same thing as saying 1 minus cos squared X. Fantastic. Good. Well done. So that's what I would do, guys. I would start by doing that. And what I'm going to do, because we're running short on time here, I cannot believe how fast an hour goes. Kia, I don't know about you, but I don't know where this hour has gone, or this hour and a half.
It went by very quickly.
I'm telling you. Okay, I am going to take a picture of this answer for you guys, and I am going to put it into, I'm going to put it into the chat so that you can see it. So I'm going to put it into, okay, so let's move it for you guys so that you've got it there. You can take a photo of it, and you can go from there. Okay, so there we go. We change it into 1 minus cos squared X. We multiply out the brackets. Okay. Once we've multiplied out the bracket, we can then take cos X out as a common factor. And we then solve for X. All right. Okay, guys, take a screenshot. I see loads of you saying here that you didn't receive this paper. or it's different to the one that you did receive, I am going to ask Watobe again to send it to you guys so that you've got this one. I can tell you that this paper that we have been doing over the past 2 weeks is from it's the KZN paper from 2019. So it's the 2019 KZN paper. It's a really good paper, as you guys have seen. Really great practice. There's also some really nice geometry in it. I feel like we could have had another lesson on this paper, probably for next week. So I will suggest that for the June exam that we have loads and loads. Please make sure, so it's KZN, thank you so much, Kia, KZN paper 2, 2019 June. Go and have a look at it. All right, make sure you go through it if you want extra practice. But like I said to you guys as well, I've given you lots of different places to go get practice. I see somebody's raising their hands in the picture. If you don't have any other questions, you're more than welcome to log off the chat. Thank you so much for joining us, guys. I hope that you're going to tackle trig in your exam. I hope that I gave you some hints and tips and some things that are really going to help you. Or we're not doing Euclidean geometry. Euclidean geometry, we did that last week. Unfortunately, we're not going to have time today because we are at the end of our lesson. I'm really sorry, guys, that we didn't get to it, but go and have a look at this paper, go through it, go make sure you do the questions yourself, okay, and get to them. All right. Kia has put a poll up for you. Please make sure that you answer that poll. Okay, before you log off, please make sure you answer the poll. All right, if you have any questions, please raise your hand. I can answer your questions in the meantime, just while we're taking the poll. Otherwise, thank you so much. Have a wonderful Sunday. Good luck with your exams and goodbye. Okay, a reminder to please make sure that you are answering the poll before you log out, guys. And we will see you in class, or your teacher will see you in class this week. Good luck with exams. Thank you, Kia. Okay, Kia, are you all good? Have you got the poll?
Yes, I do.
Okay, guys, what I'm going to do for those few of you who are left on the chat and those who want, oh, dear, it's logged off, sorry. Those of you who've want more practice is I'm going to go and put the questions for the geometry on the page for you, and you can just take a screenshot of that, because I'm sure that some of you would probably want to do some practice and you might not get a chance to go and look for this paper. So I'm going to move down to the geometry for you. So if you want to take a screenshot, you are more than welcome to. You can go ahead. I'm going to give you a few seconds. So if you want to take a screenshot, go ahead, take a screenshot. I would suggest, though, go and finding this page. I tried to send it to you, but unfortunately I couldn't. So take a screenshot, move it down. What I'll do as well is I will bring the memo across for you as well. Okay, take some screenshots. You can see I've had a few students taking screenshots the whole time. Well done, guys. All right, I'm going to move it down a little bit more for you. Okay. And a little bit more. Right. I'm going to bring the paper across from you guys and just for you guys and just bring the memo up so that you can get the questions in the memo as well. So give me a few seconds while I bring that across for you. Okay. So literally that's how the paper comes out from Stanmore. It's fantastic. They got such a wonderful site there. I would really suggest going and looking at it, guys. All right, so let's find those questions for you. Okay, so there is the geometry questions. I'm going to move this out of the way for you. All right, so there is the memo. You can take a screenshot of that. All right, move to the next page for you. And there is the screenshot of the last page of the memo. Okay, good luck.